Right, good evening. Uh, Thank you for making time and thank you for being patient. Right. We are going to have an extended session today. Right. So we're going to go about the hour mark. I understand there are some people. For those who had a class with Ed, I'm sure he has informed you that that is going to come at 8:30. So I just wanted us to have a go and have a discussion at machine learning. And then after that, we can just look at questions, and then we should be prepared for the revision classes when we look at more questions then. Right. So far, under artificial intelligence, we have looked at problems, right? We have defined the problem space, and we said for a problem state space, you need a initial state, you need an action, and you need the results of the actions, right? That defines the state space, and then additional to the state space, you also need the goal test and the cost function, right? For you to fully define a problem. Then we moved on into searching. We said the searching is the process of finding a solution given a problem, right? So you search for a solution, right? Then we looked at adversarial search, where we're saying, okay, you've got two people or two groupings or opponents or comparative agents that are in a specified environment looking for or fighting for the same resources, right? So we looked at adversarials, we saw how that happened, and then we also see, I think we then looked at constraints, right? So what about constraints? We say that though you might want to do 5, right? Though you might want to speed and drive above 120 kilometers an hour, there's a restriction against that because of the law, right? So even though you might want to do something, there might be restrictions that may be within your control or may not be within your control, and we call that constraints. So for you to satisfy or to give a solution for a problem that has got constraints, it means you have to satisfy all the given constraints of that particular problem, right? So all that now, how does it fit into machine learning, right? Because at the beginning, when we looked at agent programs, right? We said agent programs control the or are responsible for deciding or getting to the output, right? So in one of those agent programs, we had one that we called learning, and we said that learning could be applied to any one of the agent programs that we discussed: simple, reflex, model-based, utility-based, goal-based, right? In any case, right, learning could be applied to any of those. We do not go deeper into learning, but we're going to look at what learning entails from this point in time, and then we can proceed. Right. So now an agent improves its performance by learning. Right. Driving, for example, right? When someone starts driving, it's going to be a struggle. You're going to look at the gear lever when you're changing. If it's a manual, you're going to be even your posture when you're sitting, everything is going to be different. If you then gain experience, you can tell someone who's still learning to drive and someone who is experienced driving, right? For someone who has got experience, it comes effortlessly, right? Because they've improved through learning, right? A baby growing up, walking, crawling, walking, getting off the bed, all of those things, they are learned behavior. Languages, right? Those are learned, right? Even if an example would be, right? So if you take someone, a baby from an English-speaking family, and they are raised by, say, for argument's sake, a French-speaking family, they will first learn French before, or they can grow up knowing French and never learn English, right? So it is because they learn, right? They continuously improve themselves to where we are right now. It is because of learning, right? So why do we learn? We learn because it improves our decision making in future, right? If you have ever hit your head on the corner of a window, or if you have ever hit your toe on a corner, on a corner of something hard, right? You'll be worried next time not to repeat that same mistake again. Why? Because the lessons that we learn sometimes as human beings are very tough. The pain that you have to go through to learn that lesson is very, very tough. Right. So we learn so that we do not, or we get a better performance measure in future tasks, right? You become say for example, no, it's a common stereotype that guys in relationships are bad at communication, right? If at one point the reason was you could not communicate effectively and you were left because of that, right? You try and overcompensate, try and compensate for that in your next relationship, sort of, right? Whatever experience we get, we learn. So there's a common saying that either we win or we learn, right? Either ways, we're still learning. So learning can range from trivial things, right? For example, like I'm saying, a game show, right? You can learn something new every day on a game show, whatever the case is, right? It's something that is trivial, right? You can remember a phone number is trivial, but you can get to something that is far much more complex, right? So here the example is given by, say, Albert Einstein, right? Theory of the universe. You are now talking about how time differs at different dimensions and so forth, right? That's way complex than learning 1 plus 1 is equals to 2. Learning, which is more complex than learning integration by parts, which is less complicated than doing other things, other derivations, deriving Maxwell's equations, and so forth and so forth. Right? So learning can then be classified into different aspects of it. Right? So what is important is, especially as a human being, is you keep learning. There was a statement that always sticks with me that says, the moment you stop learning, you die, right? So you start dying, right? So learning is an inherent part of us. What about for computers? What about for computers? Up until now, all the machines we've been building, for those of you who have been with me through the other modules, we talk of theoretical computer science, when we talk of DPDAs, when we talk of Turing machines, right? All those machines, finite automata that we have done up until now, right, were only capable of carrying or doing repetitive tasks, right? They were only capable of doing repetitive tasks. So a part picking robot, right, is going to pick a part, do what it's supposed to do, and stop. Pick another part, do what it's supposed to do, and stop. So they were designed to do those repetitive tasks that human beings could not do effectively because of the high error rate or whatever the case was, or when it was dangerous for human beings to partake in those, right? So mixing chemicals, in nuclear reactors and so forth, right? So quickly machines were developed to do that. Right. Most advances in machines, or what machines could do, came during war times, right? You've got the radio developed during war. You've got the technology of ships, right? Most of it dates to the First World War, right? Most of the advancements but they were meant to do jobs that were dangerous for human beings, that were repetitive, and so forth. Now, in terms of another one, I think it was Blue Ivy. I think it was Blue, the first machine to defeat a human being. Right. So it was not learning as per se, but it had set rules, if then implications, if then, if then, if then. Right. So that was the machines that were there then. Now, learning was first proposed, I think, in the early 50s or something. Right? But there was a time that it died, right? Up until now, where it is a big thing, machine learning, artificial intelligence, and so forth. Like we mentioned in the first class, we do not have the right equipment to do it, and so forth. But now that we're doing, it's a big part, and it's a very big component of what you're going to be doing. This is an exit level module. If you want to take this further, this is a very interesting field. I'm passionate about it. But yeah, it's a very broad field. What we're going to look at now is just a drop in the ocean of what it is. Right. So any component of an agent, right? Any component, if not even the full agent, any component of an agent can be improved by learning from data. Right. So it depends on which component do you want to improve, what prior knowledge does the agent already have, what representation is used for the data and the component, what feedback is available to learn from. Right. So at the beginning of our course, we said that one of the biggest issues was the computing power, number one, and number two, it was the lack of data. So one of the big enablers of artificial intelligence is big data, right? Big data. So what the presence of the data and the representation of the data, is it structured or is it unstructured? Right. So this presence of data nowadays allows for us to make better decisions. Right. So those are the major factors that can tell you which component of an agent you want to improve. Right. So for example, if you've got an eyesight problem, what is going to happen? You are the agent. You identify the component which needs to be improved. It is the eyes, right? What prior knowledge do you have? So you can already see when you do the test, you see that you can see you're far-sighted, short-sighted, whatever the case is. And then maybe representation of data is not going to be important here. And then once you give we've won the specs, you can give feedback and then say, okay, they are achieving the goal or they're not achieving the goal, and then you can go on. Right. So this is the age where we are at right now. We're hearing things like automation and so forth and so forth and so forth. What is already existing, we want to identify components that we can improve. Right, so we've got three forms of learning that we can talk of. We have unsupervised learning, right? So in this case, an analogy is to take for some of us, this is how we learn to swim. You get thrown into the deep end of the pool, and then people will just be looking at you. Then you fight with the water for a few minutes. Then you say, okay, I'm not drowning, I'm floating, and then life goes on, right? So unsupervised learning, right? The agent learns from patterns, right? Even though no explicit feedback is applied, right? So unsupervised, we are saying, machine, agent, here is data. Do what you may with this data, right? So either it will come out with a very good model, right? Or it will come out with a bad model. The output at this point is not important, right? So the most common unsupervised learning task is clustering, right? So is this a brain tumor? Is this not a brain tumor? Is this a human being? Is this not a human being, right? Facial recognition, softwares, right? You are clustering, you are saying, is this a face? If it is a face, you put that bounding box on that face, then you can do that. Right. So a taxi agent might gradually develop the concept of good traffic days and bad traffic days. Right. So a Google self-driving car, for example, if you have a Google self-driving car, if it is every day it's collecting data. So on Monday it goes, on Tuesday it goes, on Wednesday it goes, on Thursday it goes, on Friday it goes. It does that for a month. It can end up clustering and saying, okay, Tuesday is a bad traffic day. If I want to reach point B at 8:45, I have to adjust my starting time. Right. So it can then come to the point of saying it is impossible on Tuesdays to arrive at destination B at 8:45 if I leave at the prescribed time at 8:40. Then the output can then be to say adjust your time, and then you can make better decisions. Right. Now, that's unsupervised learning. Then we've got reinforcement learning. So this is the type that you, when dogs are being trained, when monkeys are being trained, this type of learning is done, right? When we were still in primary school, my teacher, if you got 10 out of 10, there was this purple star that would be put on your book, right? It was very rare. So for you to get that star, you had to get full marks 10 out of 10, and you really need to have good handwriting, right? So it was a unicorn, and we all yearned to get that star, right? So I maybe only got it once because my handwriting wasn't that proper. So I only got it when I was the only one who got 10 out of 10. So that's reinforcement learning. Agents learn from a series of reinforcements. So if someone does a good thing, right? If your child does a good thing, then you reinforce. You give him or her, you give them a sweet or whatever the case is, right? If you're a good employee at work, you receive a bonus, right? Reinforcement learning. If you're a bad employee, you don't get a bonus, right? If you're a bad employee for the whole year, you don't get an increase at the yearly review. All that is reinforcement learning, or aspects of reinforcement learning. So you can either be rewarded or you can be punished. You can either be rewarded or you can be punished. Right. So if Uber, for example, or in a restaurant, if you are really happy with the service, you can tip. But now I think tips are compulsory, so this may not be a good example. But you can get a tip at the end of your journey. Like, okay, keep the change, whatever the case is. Right. So if it is a norm that if you do something good, you get a tip, the day that a customer, even in a restaurant, says, no, I'm not giving any tip, right? It serves to inform you that you did something wrong. So what you're going to do is, because you still want tips, you are still going to look for what was wrong and correct what was that wrong, and not do it again. Right. So in a game of chess, the winner gets 2 points, so you feel good about the 2 points. The loser gets 0. Well, you don't get anything if you lose, right? So knowing the reinforcement, using the reinforcement learning technique, the agent has to decide afterwards to say, okay, this has led to me getting a sweet. This has led to me getting a bonus. This has led to me. So if you are working overtime, right, and not claiming for it, and then you get a bonus, it becomes a norm, because you realize, okay, if I continue working overtime, I'm still gonna get a. This is the behavior that is tolerated, and it leads to a certain output. So that's reinforcement learning. Then the last one is supervised learning, right? So in supervised learning, there's a data model that you are given first. There's a data model that you are given first. So imagine when you are still driving, you go to a driving school. So before you even start driving, they start telling you how driving should be done, right? So you then go and you say, okay, this is a steep hill, right? You have to do hill start, right? And then you have to put the handbrake on, you have to do the steps, everything, and then you go, right? Now, when you are faced with a similar scenario later on, right, you are able to discern yourself to say, okay, this is a hill start. The car is likely going to move back at this point. Therefore, I'm going to effect the process, do hill start. Right. So you have got somewhere where you are learning from. You have got a supervisor who's saying, okay, no, that is not the good way to do it. The good way to do it is this way. That is not the way you do it, and so forth. So that is supervised learning. That is supervised learning. In image processing, right, you have a bunch of images, a million images that you go and you train. Say you want to train an agent to identify animals of the jungle. You are going to go with a million images to it, and then you say, or maybe not a million, but thousands of images to it, and then you say, this is a zebra, this is a lion, this is a donkey, this is a zebra. So you want maybe 100 different pictures that represent a zebra. Maybe at one time you want to give the whole picture of a zebra. At the other time, you want it to be able to identify, say, an elephant, right? There's a story that is usually told of 5 blind people who were told to, they were each made to touch an elephant, right? Different parts of an elephant. And then afterwards, they were then asked to define or to describe an elephant. So the one who touched the trunk defined something long, right? And then the one who touched the tusks, something hard. It was not as soft, or the description of the trunk and the task were different, of course. The one who touched the hind quarter felt something that was flat, right? So from all day, it was flat all the way, all the way, all the way. So he or she could not understand that it was thin and long, right? So the different parts of a body, right, would need to be presented to the agent for them to know or to definitively be able to identify in some object. For example, most days or most times nowadays, you are required to do capture, right? So a capture, what it does, it says, give all the squares that have got a motorbike, right? Identify all the squares with a motorbike. They are not, some of the pictures will not have a full motorbike. It will have the hind view of a motorbike and the exhaust, right? Then because you are an intelligent being, which computers are not yet, you're an intelligent being, you are able to identify the parts from the whole, right? So when you want to teach a fellow agent who is a machine that this is a motorbike, so you can give them a picture of the whole motorbike, and then tomorrow when you want them to identify, you give them a smaller part of the motorbike, they are not going to be able to classify it as a motorbike. So you give them different aspects or perspectives of a motorbike. Yeah. That is how you are then able to identify an element. So that is supervised learning. That is supervised learning. Right. Before I talk about entropy, are there any questions on the theoretical aspects that I was touching on for now? Now let's talk about entropy. Right. Anyone familiar with the term entropy? Anyone with the familiar with the term entropy? So it is used in multiple it's used in different scenarios. In thermodynamics, I know it's there, entropy is there. But when we are talking of entropy, we are talking of the natural state of order or natural state of disorder, right? So there's a statement, people don't like it, but say disorder is the natural state of order. Is the natural state of order. Right. Do I have proof that this is true? Not yet, but I believe so. Why? Any natural event, any natural occurring event, it does not seek to bring order or as per se, but if you look at a hurricane, it destroys, right? Then maybe the aftermath of the hurricane might be good. It brings fluvial soils and so forth and so forth and so forth. But disorder is the natural state of order, right? So entropy, the idea of entropy supports that. The idea of entropy supports that. So you can have 0 and then you go from there, right? So when you have less information, what is happening if you have less information, right? You are in a position where you know little, right? Now, the quest is then to gain knowledge as you go, right? So entropy in information technologies, we are sitting here, it refers to the current state of knowledge. Let us look at it as the current state of knowledge present. Right. Then, knowing that you know so much, then you can then gain some more information and become more knowledgeable. Right. Now, if you know everything about something, right, it means there's nothing more that you can gain. There's no information gain that you can come across. Right. Entropy is saying, what do you know about this current event or what is currently happening? How much of it do you know? That is what we can speak to for entropy. So over here, it is given as the negative or the negative of the P log P. Right. So P over here represents the probability of something happening, probability of occurrence. Right. So the chance that it will rain is 20%. So that is the knowledge that you have. You now know there's a 20% chance of it being raining, Right. If you are told there's a 20% chance of rain at 9 o'clock, right? And then at 10 o'clock, you see clouds gathering, right? The probability of rain is going to increase up until you get the first drop, right? So that probability is going to be raining. So probability is a decimal, so it's always going to be 0 point because probability is from 0 to 1. It's a decimal, right? And then the logarithm of a probability, or the logarithm of a how can I put it? The logarithm of a decimal is negative. Right? Check it out on your calculators. Log of 1 is 0. Log of log of how can I put it? Log of 1 is 0, right? Log of 10 is 1. So it's going like that. But log of anything to the decimal, it will be negative something. Right? So that is how logarithms work. Now, here the log is 2 to base 2, which is something that we're going to discuss as well. Now, I want you to look something about the entropy. Right? If the probability is 1, then the logarithm is going to be 0. So if we have perfect knowledge, then the entropy is going to be 0. Right. If we have perfect knowledge, the entropy is going to be 0. All right. Now, another related concept is called gain, or the information gain. The information gain. So, how do you do it? You're saying the entropy of S, right? So whatever that we got, the entropy value that we got, then we have got over here the S values. So this is a variable actually. Then we have got the chance of that variable happening over the entropy of that value. So we're going to see when you look at an example how exactly that works out, right? So we're gonna need an example for this to come out proper, right? So where does this information feed into? Today we're not going to do a proper question from the exam. I'm just trying to break down machine learning so that when we look at a proper question, it's going to become variable. So I think we're going to look at that tomorrow. Right, so the National Credit Act introduced in South Africa in 2007 places more responsibility on a bank to determine whether the loan applicant will be able to afford it. Blue Bank has a table of information on 14 loan applications. Right, which type of learning is this? Reinforcement, supervised, or unsupervised? From the statement that is given, which type of learning is this? Which type of learning is this? Anyone? Which type of learning is this? Reinforcement, unsupervised, supervised. Right. So Anthony, supervised. Why do you say supervised? Why not reinforcement? Why not unsupervised? Any justification?
All right. I think it's because we are given to say a parameter and we determine whether the risk is high or low. So we are essentially guiding the bank or whatever we give this table to say this is high risk, low risk. Given an input, then you give it a corresponding output. So that's why I think like that.
Right. So the shorter version, or more accurately, it is supervised learning because we've got training data. So we call this training data. So it says to the machine, okay, this is how we have allocated risk before. This is how we've allocated risk before. So from this, learn and then be able to determine high risk, medium risk, or low risk. Right. So the presence of a data set is key to supervised learning. Right. So that's yes. So Gideon, the existence of a data set, right, is the one that will inform us about the type of learning that we're going to have. So there's a new bank, Discovery Bank. Right? Discovery Bank determines risk based on a different model than before, right? How do you think their model works? Do you think it works on supervised, unsupervised, or reinforcement? I don't know if you're familiar with Discovery Bank. They've been big in the last 2-3 years, last 2 years actually. So anyone who, if you're a Discovery Bank customer, right, if you save money, you get better interest rates, right? If you don't save money, so for now they are not doing negative reinforcement; they are only doing positive reinforcement. So if you drive better, your insurance premiums decrease. If you save, you get lower interest rates. If you are a non-drinker, right, so they can track your purchases and so forth. So they reward a sort of good behavior, or what is deemed to be good behavior. That is what is rewarded. So they use a concept, or they borrow the concept of reinforcement learning to say, okay, this one has been good, so we reinforce, we give them something for that. But anyways, back to this now. You want to determine when a customer walks into your front desk whether someone is a high, medium, or low risk person to give a loan to. Right? Now, given this table, you have got 4 inputs that can tell you about, so 1, 2, 3, 4. You have got 4 inputs that can tell you about a person's risk status. So, which question would you ask the person first? Which question would you ask the person first? Right. The mathematical implications of that question is to say, which question gives you the most information about that person first? So when they come in, you don't know anything about them, but you want to know more about them so that you know about their risk, right? So what is the question that will give you the most information? So there's an income, right? So income, say income gives you the most information. So you're going to say, what do you earn? Right? What do you earn? Right. If you earn above 35,000, right? Those who are earning above 35,000, I've got low, I've got medium, I've got low. So those that are earning above 35,000 are classified as low to medium, right? And then those that are classified between 15,000 and 35,000, I've got high, I've got medium, I've got high and medium. So all of these are high and medium, right? So 15 high, 15 medium, 15 medium, 15 high, right? And then those that are under 15,000, I'm going to get a classification of what do I get over here? 15,000 less than 15, I've got high, I've got high, I've got high, and I've got that's it. So everyone under 15 is going to be high, right? But how do we get to the point of saying income? Why don't we decide? How about if we look at why not look at collateral? Why not look at collateral first? What is preventing us from looking at debt first? What is preventing us from looking at credit history first? So those are the questions that we are asking. What leads us to say income? You have to ask about the income first. Right. So let's look at the other ones. If you are in debt, if you have got high debt, right? Those that have high debt, these are high risks. This one is high debt, but it's a low risk. This one is a high debt, high risk, high debt, medium risk. So knowing that someone is a high debt does not, or gives us three options: high, medium, low. So we still have the options that we had before the person entered. Any person would have it. Right. So asking about the collateral, if a person has collateral, right? If a person has collateral, I'm getting medium and low, right? And then if they don't have collateral, I'm getting low, high, and medium. So if a person walks in and tells me that they don't have collateral, I'm still gonna be on the same level that I was before. Right. Then what happened? We look now, credit history. Right. If the credit history is bad, right, we've got medium and high. Right? If the credit history is bad, we've got medium and high. If we've got credit history unknown, we've got medium and high. If we've got credit history good, then we might not know that much about. If the credit history is good, we've got low, high, and medium. Right. So we are saying at this point, right, the best one that can classify for us is the income. Because once I know the income, so I'm going to say the first question I'm going to ask is the income. Right? Income. So if I ask the income, I've got three branches for the income. I've got less than 15,000, less than 15K. Then I've got 15K to 35K. Then I've got greater than 35K, like that. Right. So these are the branches that I have. These are the branches that I have. Right. So based on this, I can then ask another question. So if I know that you have got less than 15,000K, right? What is the output that I get? I know already that you are a high, right? You are a high. Anyone who was earning less than 15,000 was a high income, was a high risk, right? So this question already signifies or gives me the risk. I get the risk of this guy by just asking one question. Now, say I know that you earn more than 35,000 rands, right? What is the right question to ask at this point? I know you already earn 35,000 rands and above, so I'm restricted now to only this class of people. These are the guys that I'm asking now. If I know that you earn 35,000 rand, right? What other question can classify for me or be the quickest for me to identify their risk profile? What else? What is the next thing that I can look at? What is the next question to ask those who earn more than 35K? Any takers? What is the next question? All right, so Gideon says collateral or debt. When you are saying collateral or debt, are you saying they've got the same impact or the same they've got the same effect on the risk? Question back to you. Question back to you.
It's just easier to not type. I'm not too sure. I was more looking at just the available options in those two other categories.
So
there's the 35,000 people have got either collateral yes or no, or they've got low or high date.
right, so these are the people that we're looking at, right? So out of the 5, it's 1, 2, 3, 4, 5. Out of these 6, right, we've got low, we've got low, we've got medium, we've got low, we've got low. So we've got low and medium, right? So what makes this one have so for others with low, these ones are low risk. So let's look at debt first. This is low risk, low debt, low risk, low debt, and then this is low, medium risk, low debt. So low debt still gives us 2 options: high and low and medium, right? And then we also have over here, it's high debt, low risk, right? Now, let us look at collateral. Collateral, we have got no collateral is low risk. Does have collateral is low risk. Having collateral, high risk. Having collateral, low risk. And over here, no collateral, low risk. So it's still giving us the same low and medium, right? Let's look at credit history. If you have got an unknown credit history, unknown leads to low. Bad credit history and N above 35 leads to medium, and then good credit history leads to low, right? So I think the good question to ask is about the credit history now. What do you think? Because people with earning more than 35,000 K and have an unknown credit history are low risk. People with so what I'm saying is, when you get here, you ask the question of credit history, right? So we have got low, we have got medium, or you've got good, you've got bad, and you've got unknown, right? What we see is that anyone with an unknown who earns above 25 is getting low. Anyone with a bad credit history earning above that is a medium, right? Anyone earning above 35 with a good credit history is a low. So already we have classified, if you're earning above 35,000 and you have a good credit history, you're a low risk. If you have bad credit history, a medium risk. If you have a non-credit history, you are a low risk. Right. So that is classified for us faster. This would have been compared to, let me just see, for example, if I were to ask the question of collateral, it's yes or no, right? So it's yes or no, if this was collateral, right? If this was collateral, you have yes or no. Over here, you still, under no, you are still going to have 2 options, right? You still need to ask another question. So the credit history tells us more information, or it allows us to get to the solution quicker than anyone else. Right. So at this point, you have asked the credit history, we are fine. So we're done with income, credit history. We're done with less than 15,000. We're done with above 15,000. Now we want to deal with this 15 to 35K. We want to deal with this 15 to 35K. So 15 to 35K, who are we talking about? We're talking about number 1, number 2, number 3, and number 4. Only these 4 people. So for these 4, we have got high, medium, high, medium. We've got high, medium, high, medium. Right. So collateral gives us these 2 have got no collateral, they are still medium, right? We don't have anyone with collateral, so no collateral does not really tell us any new information. Or the question of collateral does not tell us any new information. Right. Then we have got debt. We've got high debt, low debt. We've got high debt, high debt. So high debt is leading to medium and high, right? Low is leading to medium only. Right. Then if we look at credit history, unknown is leading to medium and high. Then we have got good is leading to medium, and then bad is leading to high. Right. So these 2 are good to work with. These 2 are good to work with. Right. Because they give us information. If we are asking, if we are then asking about the credit history again, if we ask about the credit history, if it is good, if it is bad, if it is unknown. If it is good, we know that it is going to be, there's only one good over here, sorry. There's only one good, it leads to medium. So this leads to medium. If it is bad, right, it is not leading. If it is bad, just need to delete one of these. There we go. If it is bad, right, we've got only one bad, it leads to high risk. Leads to high. If it is unknown, it leads to something that is not decisive, it leads to medium or high. Right. So now we are now focusing on these ones. Everyone else has been dealt with. We are now only focusing on these 2. Right. So we have done income, right? We have done credit history, it's unknown. What else do we know? What else do we know? So income and credit history. So what else can differentiate? Them not having collateral still does not tell us any information. But if they are in high debt, they are high risk. If they are in low debt, they are medium risk. So we can then come and say, okay, now I'm asking about your debt. So your debt, if your debt is high, low. If your debt is high, low, then you are medium. If your debt is high, you are a high risk. Right. So what we have done essentially is we have modeled how we can a machine can perform or get to a decision. Right. Now, this is how we make, I think, as human beings, we make decisions as well. You look at a choice, is it good for me, is it bad for me? If it is good, you go for it. If it is bad, you leave it. Right. So human beings are natural classifiers. Right. We have concepts like beauty, we've got concepts like we've got shoes that are different and someone prefers others to others. We've got cars, we've got all that. So we naturally compare things, right? So this is what is going on in our minds subconsciously as we attach value to it, right? So there was that example that I gave in one when we were talking about agents, utilities. When you say you are driving a vehicle, right, you are definitely going to hit 10 people over here, or you're going to hit your child here, right? Which way are you going to, which way is your car going to go, right? So because we naturally assign value to our decisions, it will be an easy decision for me to say, okay, my child is safe, I'm going to go for these 10 people. I'll sleep better at night knowing that I hit 10 people and I saved my child, rather than killing my child to save 10 people that I don't know. Unethical, not ethical, right? But we will have different reactions to this scenario depending on what we attach the most value to. So banks, when they come and they say, DSA, you are a high risk, right? So when you go there and they say, please show us your payslip for the last 3 months payslip, and they say, see less than 15,000, already high risk. What interest are you getting? Prime plus 2.5, the maximum, whatever. Then you get that, or plus 3, right? Then when someone else comes and then they say, I am earning more than 35,000, they're going to be, okay, well, you're a low risk, say, you're going to get prime plus 2 or plus 1.75, whatever the case is, right? So those two people already are different, right? And if you look at it from the bank's perspective, why are they giving someone with a low income high interest? Because their defaulting rate is perceived to be high. So they want to recuperate as much as they can before this person defaults. So banks are a very good example of when you get into you don't sign the marriage contract before anticipating divorce. Right? So that is what these banks are doing, or how the system works, right? Because they themselves, they can be managed from the back end to say, why did you give this person money knowing very well that it was a high risk? Right? So that's a question that they have to answer themselves. So that is the concept of decision making. Where does machine learning come into play here? Now, this was a training model that says, look, this is a high risk and this is a low risk. That is how we've been classifying before. Now, machine learning will then come and say, this is the model we've been using. We have got classifications, you've got high, low, you've got medium. Let me do this on a new page. You've got high, low, and you've got medium. Right. Now, we continue getting more and more people coming in. Right. You continue getting more and more people coming in. Right. Then we see that, okay, this data that is coming in, we have people, so we have given this one a limit to say you can get a bond for the one lending less than 15,000. The limit to their bond has been given to say, well, let's give them, let's say 600,000. So you can only buy a house with less or equal to 600,000. 15 to 35, okay, let's put it at 1 million. Above 35, maybe be above 35, less than 50, or kept at 50, maybe we can keep it at 2 million, right? So these are the bond options available for these people. Now, when they see, or when you look at behavioral banking now, or when you look at machine learning now, machine learning would then say, we have given this person 600,000. They have a good credit record. They have they've been paying on time, right? Previously classified them under medium, right? So are they consistently having a bad credit history, right? Is their credit history staying at high? If it consistently stays at high, then you are not leaving the medium that you're classified under. But then if you then move from medium, say, to low credit history, right? And more people are behaving like that, At some point, the machine might then say, and this is where machine learning comes into play. So we initially have this, right? 3 distinct ones. We might end up having, we have got low, we now have an intersection with medium, all right, and maybe not high risk. There's no intersection so far. So this set of medium risk people is now growing into this intersection of low risk people, right? And then we have got a decision to make here. So they have to make a decision there. So they can then expand the sets, or they can create, eventually what these machines end up doing, they end up creating a new set on their own. Someone that is between there, someone that is between there. Maybe they can be increased there, whatever, offering to 800,000. So because of this, the computer is now learning as more data comes in. As more data comes in, it is then able to classify. It is then able to classify. Hence, that is supervised learning in a nutshell. Right. Any questions so far? Now, let us conclude today's class by looking at this table over here. So these are the logarithms that we're talking about. We're going to look at them. So tomorrow there's a class. We're going to look at them in tomorrow's class when we finish, or we wrap up on machine learning. So, but these are the logarithm tables that we're going to be using. It's 2 of them. There's this one, and then there's that one. And I'll explain how they are used differently, in what scenarios they are used. But generally, you can also use your calculator to do these calculations. If your calculator is smart enough to do base 2 logarithms, right? Or you're familiar, you've done it. So I don't want you to try new things in the exam. I don't advise it. But when we look at questions tomorrow, we're going to see the application of these 2 tables, the different scenarios that can happen. All right. So that is machine learning, ladies and gentlemen. So this is just the tip of the iceberg. You then go and see, when you look at classifiers, you've got the fuzzy algorithm, you've got, there's a lot. You've got neural networks, you've got genetic algorithms, you've got, so that part, because we did not do that part, I think it was chapter 4, that is called optimization. So the agent can then optimize the algorithm to make it better. Right? What does it do? It's called optimizing. Right? So it then fine-tunes the decision making so that it becomes much more accurate. We classify much more accurate. All right. Any questions? Okay. If there are no more questions, then we can call it an evening, right? What I'll probably do is I'll then upload a video under additional courses. So just check 30 minutes after our class. I'm going to upload another video on machine learning that tackles an example. Right? That video is going to tackle an example of machine learning. I think it's going to deal with the with the 3 different scenarios. Yeah, if it is not, I'm just going to confirm if it is a video, it's a PDF where I do it, that we can just go through. If it is not a video, then we're going to go through the PDF tomorrow. But thank you very much for attending. Again, I apologize for starting the class late. Enjoy the rest of your evening. Good night and goodbye.